Alright, so implicit differentiation, there are a few things that you're going to have to be able to do. You want to be able to find the derivative using implicit, and you always want to double check the with respect to variable. Make sure you're paying attention to that. You want to be able to find the second derivative. You want to be able to find equations of tangents or normals. You should be able to find where horizontal tangents occur and where vertical tangents occur. So here is the first problem. We're going to find the second derivative. Go ahead and press pause, and then you can try the problem, check your answer. So, here we go. First derivative, 2/3 x to the negative 1/3 plus 2/3 y to the negative 1/3 times dy dx is equal to 0. So dy dx, move this term over, it will become negative, divide by this term, and you get negative x to the negative 1/3 over y to the negative 1/3. And in another video, I think I simplified that more. Because these are negative, you could flip the fraction, and you could get negative y to the positive 1/3 and x to the positive 1/3. I don't really care if you do that or not, because the question is not what's the first derivative, the question is what's the second derivative. So, in case some of you don't do that, I'm going to use this as the first derivative. So, to find the second derivative, you take the first derivative's derivative. So, that's a quotient rule. I'm going to give the negative to the top of the fraction so that I don't forget about it. That's usually the best way to avoid forgetting the negative. So, log d of y will give me positive 1/3 x to the negative 4/3 minus half, which is positive half, d of y, which is negative 1/3 y to the negative 4/3 dy dx, all over y squared. Alright, so right here I'm going to input the derivative. So what I'll do is physically just erase the dy dx part. I'm going to take a picture of the derivative, and I'm going to move it over. There it is. Okay, so that is physically the first derivative being placed in there. So I want to simplify it. This is the part that a lot of you guys struggle with. So here I'm going to put the 1/3 in the front. I have y to the 1/3, negative 1/3, oopsie, x to the negative 4/3. Here I have this negative and this negative, so that would become a positive. Same thing, I am going to put the 1/3 in front, and in this case, because I have a fraction already, I'm going to treat this as a fraction, and I'm going to put the 3 in the denominator. I have negative 1/3 power times negative 1/3 power to be negative 2/3 power, so that would be 2/3 down here of negative 4/3. That's minus 1/3, so what do we get? To the negative 1 power, so I actually get y down here. I think I end up with nothing in the numerator. How did I do that? I know some of you are probably extremely confused. So if you are, the other option you have is to write it out, negative x 1/3, that'd be x to the negative 2/3, and then y to the negative 4/3 divided by negative 1/3 means to subtract negative 1/3, which will give you y to the negative 3/3, which is negative 1. So I just actually took that and moved it. Now, I still have this guy here. So this piece, I'm also going to rewrite, let's hope I can remember properly. I should have done it in the beginning. I'm going to turn that into a fraction also. So I have a 3 in the denominator. I have x to the 4/3 in the denominator, and I have y to the 1/3 in the denominator. So I need a common denominator. common denominator would be highest power, so x to the 4/3, and then over here, y. So the GCF, greatest common denominator, GCD, is 3x to the 4/3, and then y. So to get a common denominator here, I would need on this side just y to the 2/3 over y to the 2/3. To get the common denominator here, I would need just x to the 2/3 over x to the 2/3. Alright, that's s-thirds right there. Okay, so given that, I'm going to move over to the next page. Okay, and I'm going to make it a little smaller just to get it out of the way. Alright, so I know that I get y to the 2/3 in the numerator here. I get x to the 2/3 in the numerator here. The denominator is my common denominator, 3x to the 4/3 y, and then times 1 over y to the negative 2/3. So there's a few things we can do. If you look at the original problem, this actually was the original, and that equaled 8. So I get 8 over 3x to the 4/3 y, and then this is negative 2/3 power, which means I can rewrite it as positive 2/3 power in the numerator. And so here you end up with 8 over 3x to the 4/3 y to the 1/3. That would be the second derivative. So I did two substitutions. I substituted the dy dx in, and then this is where I substituted back the original. You don't always end up having to do that, but sometimes the problems work out nicely. Next question. Go ahead and press pause. So horizontal tangent line is where dy dx equals 0. So find dy dx. So product rule, negative 2x times dy dx plus y times negative 2 is equal to 4y dy dx plus 0, so I'm not going to write the 0. All the dy dx terms will come over to, I guess it doesn't matter, but I'll take everything to that side because it's already positive there. To this side I get 2x minus 2y is equal to dy dx times, I still have the 4y. This term is going to come over, so I'm going to add it to the other side. I would add 2x. dy dx is equal to 2x minus 2y all over 4y plus 2x. I'm going to simplify this. Divide every single term. It has to be every single term. That's the only way you can divide here. By 2. So, if that's my derivative, then to make a horizontal tangent, I will set the numerator equal to 0. I get x minus y is equal to 0. So I actually get that x is equal to y. And it's not solvable. So you don't leave it there and say, oh, the answer is whenever x equals y, because that's not true. Whenever x equals y will give you a restriction, but it won't give you the points. And I asked you for the points. So you have to take what you have there and substitute back into the original. Because there's only certain points on the curve where x is going to equal y. 5, so if x is 5, y would be 5. But if you substitute that into here, it wouldn't be a point on the curve. So I'm going to take the original, and I'm going to substitute back in. What we had was x equal to y. So wherever I see x, I'm going to put y instead. Wherever I see x, I'm going to put y instead. So I get y squared minus 2y squared is equal to 2y squared plus 4. Alright, so, let's see. Let's get all of our y squareds on one side. Let's move these over to here. So we get y squared minus, what's wrong with me? Let's do it in one step. So I got 1 minus 2, that'd be negative 1, subtract 2 gives me negative 3 y squareds is equal to 4. This sucks. I did not mean for this to happen, but we get negative 4/3, so y is equal to plus or minus the square root of a negative number, so there are no horizontal tangents. Now, if there was a value, so let's pretend that this came out perfectly, and we ended up with a value, you would then have to check your values. That's that last point that you all lost. Checking your values means take your original and just double check that those points actually exist. Those are your extraneous answers that could possibly happen. So you go back, you take your xy points that you solved for, and then you substitute them back into the original to see if it works out. A lot of times your answers have roots in them because you notice these are squared, and then because you're multiplying x and y, the square roots actually cancel, so the check is not as bad as it may seem.